Hello, I am Tom Webb and I am a postdoctoral researcher at the University of York studying the coastal cryosphere. Welcome to the Cryosphere Pavilion, and for those of you watching elsewhere, welcome to those of you in hubs in Stockholm and also in Geneva. You will have an opportunity to ask questions of your host later in the question and answer session, either here or to representatives in those hubs or in the chat. Welcome to this session on Antarctic marine ecosystems under pressure, and welcome as well to the stage Dr. Sian Henley from Marine Ecosystem Assessment for the Southern Ocean.
Good morning, everybody, and thank you so much for coming to our side event here at the wonderful Cryosphere Pavilion. So our event is focused on Antarctic marine ecosystems. Now, these ecosystems are under increasing pressure, and they really need protection through mitigation of global climate change and effective local and regional management. So I am Dr. Sian Henley, as Tom kindly introduced, from the Southern Ocean Observing System and the University of Edinburgh. And I'm joined here by my colleagues, Dr. Nadine Johnston from the ICED programme, that's the Integrating Climate and Ecosystem Dynamics in the Southern Ocean programme, and the British Antarctic Survey, Dr. Jilda Caccavo from the Scientific Committee on Antarctic Research and the Alfred Wegener Institute for Polar and Marine Research in Germany, and Dr. Susie Grant from the Scientific Committee on Antarctic Research's Standing Committee on the Antarctic Treaty System and the British Antarctic Survey. So it's a great pleasure to be here with you today. And we also have joining us online somewhere. Hi, online speakers. We have Dr. Andrew Constable and Dr. Jess Melbourne Thomas, who were the leaders of the Marine Ecosystem Assessment for the Southern Ocean, starting during their time working at the Antarctic Climate and Ecosystems Cooperative Research Centre in Hobart, Tasmania. And we're also joined by Dr. Juan Hofer from Valparaiso in Chile, who's got up very early during his quarantine ahead of his Antarctic field season. So welcome, Juan. And we are all here on behalf of the Marine Ecosystem Assessment for the Southern Ocean, or MEASO for short. And this initiative was the first such assessment for Southern Ocean ecosystems in order to gain a comprehensive picture of the status and changes in these ecosystems and what management is required in order to conserve these ecosystems long into the future. And the 7 of us presenting for you today are representing the entire MEASO team, which is a team of over 200 scientists from 19 countries. So a real pleasure to stand up in front of you today. And I just want to particularly thank Dr. Hugh Griffiths from the British Antarctic Survey, who led our social media and communications campaign for this event and bombarded the airwaves for the last few days. So thank you very much to Hugh for that. So over the next 80 minutes or so, we're going to introduce you to the MEASO initiative. We're going to explain its key outcomes regarding the importance of these Southern Ocean ecosystems and the processes that define them. And we're going to look at the processes within the Southern Ocean itself, and also their importance at the much larger scale, up to the global scale. And we're going to describe how these systems are changing now and how we are expecting them to change in the future. And then we will highlight the most important messages that come out of the MEASO initiative for policy making at global levels, such as we're addressing here at COP26, as well as local and regional conservation and management initiatives within the Southern Ocean. So to start us off, just in case we're not all Southern Ocean scientists, I'll just give an introduction to the Southern Ocean, how it's globally important, and how its ecosystems function. And then I'll hand over to each of my colleagues to go a little bit more into the story as we develop it over the next 80 minutes or so. Great, so it's always nice when the technology works. Thank you at the back. So the Southern Ocean is a vast ocean region that surrounds Antarctica. And whilst remote to many of us, particularly those living in the Northern Hemisphere, this region is actually critically important to the functioning of the entire Earth system. And that is because it has a central position in the global ocean circulation system, which transports heat, nutrients, and the greenhouse gas carbon dioxide throughout the global system. And the Southern Ocean is the region that connects the Indian Ocean, the Atlantic, and the Pacific, and therefore is a central mixing and redistributor of these ocean properties throughout the entire global ocean system. And the Southern Ocean is also critically important in terms of the air-sea exchange of the greenhouse gas carbon dioxide, because the Southern Ocean takes up a vast quantity of this gas from the atmosphere and therefore saves us from a good proportion of the global warming that we might be seeing. So this image here shows the global ocean circulation with the Southern Ocean at the center of it. And we know that the global ocean has taken up approximately 30% of the carbon dioxide that's been emitted by human activities. And of this total, the Southern Ocean has taken up approximately 40%. So it plays a critically and disproportionately important role in this ocean uptake of carbon dioxide and regulation of Earth's climate system. And all of these factors mean that what happens in Antarctica and the Southern Ocean does not stay in Antarctica and the Southern Ocean. And in fact, the changes happening in the Southern Ocean affect all of us. And therefore, we all need to care about the changes happening around Antarctica, the pressures that this ecosystem and its animals are under, and therefore what we need to do about it. So one of the major drivers of the variability in the Southern Ocean is the seasonal cycle of sea ice coverage. So we have a strong seasonal cycle whereby sea ice forms in the autumn time and retreats in the summertime. And this means that the difference in sea ice cover between summer on the left and winter on the right is incredibly stark, with the total sea ice cover varying between about 3 million square kilometers in the summer and 18 to 19 million in the winter. So huge physical variability that drives variability in the biological and chemical systems. And because the seasonal sea ice cycle is highly sensitive to warming of both the ocean and the atmosphere and the westerly winds that circulate clockwise around Antarctica, this means that this seasonal cycle is highly sensitive to climate change and is changing as a result of that global climate change. And as well as being important physically and in terms of carbon dioxide uptake, the Southern Ocean is home to a large and incredibly productive ecosystem. It comprises well-known iconic species like emperor penguins, humpback whales, Antarctic krill, wandering albatrosses, but also a huge number of lesser-known organisms like sponges, anemones, and sea stars that live in the productive seafloor ecosystems. So this image shows how energy and nutrients flow through these Southern Ocean ecosystems and how the various components are joined together by this flow of energy, nutrients, and carbon between the different constituents. So the whole process starts with the phytoplankton bloom in the center, which takes up huge amounts of carbon dioxide from the atmosphere and converts it into organic carbon, which is then used as the food source for the entire food web. So everything else in the ecosystem relies on this phytoplankton bloom. And this process of converting carbon dioxide into organic carbon also takes up a large amount of carbon dioxide from the atmosphere and contributes significantly to the total oceanic carbon dioxide uptake of the Southern Ocean. So these phytoplankton that drive the photosynthesis in converting inorganic carbon to organic carbon, these phytoplankton are then consumed by zooplankton, and zooplankton are consumed by all the larger organisms in this system that we might recognize, such as the penguins and the whales. And this has the effect of transferring energy, nutrients, and carbon into these animals that live for a really long time. So this biological mechanism stores significant amounts of carbon for really long periods of time, from decades to up to hundreds of years. So as well as being important regionally, this process is also important at much larger scales, because a lot of the organisms that live in the Southern Ocean migrate in and out of the Southern Ocean on a seasonal timescale to take advantage of the rich food resources or as part of their breeding and reproductive cycles. And this means that these organisms carry the effects of what's happening in the Southern Ocean for thousands of miles. And similarly, the effects of what's happening elsewhere in the ocean are transported into the Southern Ocean by these migrating organisms. Now, it's important to note that these Antarctic and Southern Ocean ecosystems occur in a really extreme environment. This environment is cold, there's a very strong seasonal cycle of light, so it's dark for half of the year, light for the other half of the year, and there's strong variability in sea ice cover. And this environment and these ecosystems have been isolated from low latitude ecosystems for about 25 million years. And what this means is that the organisms that occur in the Southern Ocean are incredibly well adapted to these environments and have been for a really long time. So this is likely to reduce their ability to respond to the current rate of global warming and environmental change that we're seeing, and even less likely to be able to adapt to it in order to be sustained in the longer term. And as well as the driver of global climate change, we also have an increase in human activity in the Southern Ocean, which these organisms are also struggling to respond to over the required timescales. And this means that these ecosystems are under pressure, the organisms within them are stressed, and we need effective decision-making at the global and local levels in order to protect and conserve them long into the future. So the Marine Ecosystem Assessment for the Southern Ocean has given us a detailed and comprehensive view of the functioning of this entire system, the important role that the ecosystems play, how the different components link together, and their really close association with and dependence on the seasonal sea ice cycle. So this has allowed us for the first time to provide a very clear synthesis and comprehensive synthesis to policymakers in order to underpin effective decision making, both regionally and globally. So finally, by way of leading into the following talks, this diagram, which I won't go into in any detail, but suffice to say it summarizes the large number of connections between the Southern Ocean on the left and the global scale, or the global ocean, on the right. And they are many and varied, these connections, and the interdependencies between different components of the system are really becoming clear at the scale of the Southern Ocean and at the scale of how the Southern Ocean links to processes occurring at the global scale. And in particular, the extent and the complexity of this global connectivity and the global importance of the Southern Ocean are one of the key outcomes of the Miso initiative, which will be explained in more detail in the next talk. So this brings me back to one of the very first points that I made, which was that the changes underway in the Southern Ocean matter to all of us. They affect the entire global system and its entire population. And that means that we all need to care about what's happening in the Southern Ocean, and we all need to use forums like COP26, many others, and also just increasing public knowledge about the changes occurring in Antarctica and around the Southern Ocean and what we need to do about it as a global community of citizens of the Antarctic and the Southern Ocean. So now to provide some more detail on the key outcomes of the Miso initiative, it's my pleasure to hand over to Dr. Nadine Johnston.
Thank you very much, Sian, for setting the scene to take this session forward. So as polar research scientists, we know that Southern Ocean ecosystems are globally important, that they are under pressure and they need our protection. But this message needs to be heard clearly and loudly by all nations, all politicians and relative policymakers, because we are all custodians upon them. We are all custodians and depend upon them. But to make informed decisions around climate change impacts and to act accordingly, policymakers need the right information in the right format. So this first marine ecosystem assessment for the Southern Ocean represents a core activity of the ICE program, integrating climate and ecosystem dynamics in the Southern Ocean in recent years. It draws on the scientific advances of the ICE and the wider community over that past decade, together with Antarctica's rich research history, and has formulated one of the world's largest marine ecosystem assessments. And it has produced a vital synthesis of the best available scientific evidence to inform the status and trends on these ecosystems that will inform policymakers of how how dangerous future climate change will be for these ecosystems and their services, and whether policy responses are required. So over the next few slides, I will give you a very broad overview of the MEASO outcomes and pressing upon you the urgent need of mitigation of climate change, together with more local conservation and management measures. So Southern Ocean ecosystems are under pressure. We have synthesized understanding on the past, present, and future climate and direct pressures or drivers or stresses on the Southern Ocean region, including the first spatial reconstruction of historical fisheries, which removed most of the great whales. Put simply, Southern Ocean ecosystems and the ocean itself has absorbed much of the extra heat and carbon dioxide associated with climate change. The ocean has continued to warm and acidify in recent years. Circumpolar winds have strengthened, and we have seen some changes in some areas in sea ice thickness and extent, and the retreat of glaciers and ice shelves. Collectively, these pressures have already caused changes in the physical and the living environments of the Southern Ocean. But the question is, what has been the cost to Southern Ocean ecosystems? So together with the pressures, MEASO has assessed the status and trends of past and present changes across the full spectrum of the ecosystem, from the biogeochemistry all the way through to the biology, encompassing both resident species and migrant species, from the phytoplankton to the whales, zooplankton, fish, squid, and seals, all the way from the birds down to the benthos, and food webs across a range of habitats, from the ice shelves and coastal areas, across the sea ice zone, the open ocean, and down to the benthic communities. And we've synthesized how these species and communities interact with one another and their environment across the MEASO areas out to the circumpolar scale, and the range of functions or processes they perform. And this really highlights the importance of a few key species and groups, such as phytoplankton, Antarctic krill, and benthic communities, in structuring these ecosystems and performing key functions, including carbon and nitrogen nutrient cycling and the energy transfer to support vast populations across the Southern Ocean, fisheries, and wildlife tourism. It also underlines the many adaptations to a cool and stable environment and their tight relationships with the sea ice and cryosphere and their sensitivity to ocean acidification. We have also explored their connectivity to the global oceans and the human systems across the planet, the way in which nutrients fuel global primary productivity and fisheries, far remote from the Southern Ocean. So in this way, Southern Ocean ecosystems, structure and functioning, supports global as well as local biodiversity and productivity, food security, nutrient cycling, and climate regulation, the so-called ecosystem services upon which humans depend. But crucially, these ecosystems are sensitive to a range of global and local pressures, particularly climate change. And change is already occurring across a range of biological, spatial, and temporal scales. So what of the future? Well, the IPCC assessments tell us that global change pressures are expected to continue into the future. For the Antarctic region, this includes further increases in air and ocean temperatures and increasing acidification. And pressures on the ecosystem services at the global scale will also increase. Given our understanding of the sensitivity of Southern Ocean ecosystems to climate change, future changes have the potential to cause major shifts in these ecosystems over the coming decades. These include invasive species, changes in biomass, distributions, species dominance, and food web configurations. And together with more local pressures, such as fisheries acting on the system, these may alter the fundamental overall structure and functioning of these ecosystems. So the messages from the MEASO to the nations and policymakers are clear. Firstly, Southern Ocean ecosystems form an inextricable part of our planet. They are already changing, and any alterations in their structure and functioning will have regional as well as global consequences. Secondly, whilst there may be challenges in understanding the complexities around these issues, we must take a precautionary approach and foster ecosystem resilience and preserve their structuring functioning. And thirdly, solutions lie in the implementation of global mitigation of climate change and warming, alongside more local conservation and management measures that can take account of the impacts of climate change and human-induced change. So with this overarching view of the MEASO assessment and outcomes, I now invite you to listen to my colleagues, who will give further detail on the biological and ecosystem changes and services and elaborate on more local and global solutions that are required. So with that, I will hand you over to Dr. Jilda Caccavo from the Alfred Wegener Institute.
Hi, everyone. Perfect. Just one moment. Okay, so thank you, Nadine. And I'm going to be giving you a bit more of a biological perspective in discussing the outcomes of MEASO by talking about Southern Ocean sustainability and ecosystem services. Okay. So despite the remoteness of Antarctica and its inherent inhostility of its environment to humans, the Southern Ocean ecosystems services are critical to our global society. I'm going to be focusing in particular on ecosystem services that we can define as provisioning, regulating, and cultural. And these are all ecosystem services as we as humans depend on. So we can think about provisioning ecosystem services as how the Southern Ocean provides us with food through fisheries, for example, like the fishery for krill. In this way, the Southern Ocean fisheries can support global food security. Regulating ecosystem services are the ways in which the Southern Ocean actually influences global oceans and climate. So, as was discussed earlier, the Southern Ocean has a key role in the transport of heat, carbon dioxide, and nutrients to the rest of the world's oceans. In addition, the blue carbon pathway of carbon capture of inorganic material in the Southern Ocean plays an important role in carbon sequestration from the atmosphere. And finally, if we think about cultural ecosystem services, these are the inherent value that the Southern Ocean has to our global society through its very existence on the planet. Just think about the wonder that's sparked by megafauna like penguins and seals and whales, as well as the economic value of biodiversity through bioprospecting and tourism. However, climate change poses a risk to these ecosystem services. So this table here uses the IPCC's special report on ocean and cryosphere in a changing climate to create a risk assessment of climate change to some examples of Southern Ocean ecosystem services. So the three main drivers of these risks linked to climate change are ocean temperature change, ocean acidification, and sea ice loss. So in our first two rows, we're looking at examples of provisioning ecosystem services in which we have a medium to high risk of negative outcomes. So for example, the risk for negative outcomes for Antarctic krill is high. So as described in previous talks, most Antarctic organisms are adapted to this very narrow temperature range to which they've been exposed in the Southern Ocean for over 25 million years. This means that as ocean temperatures increase, as well as increased variability in ocean temperatures, pose a high risk of negative outcomes for species like Antarctic krill. In addition, as a crustacean with a semi-soft shell, Antarctic krill are also vulnerable to ocean acidification, a further driver compounding risks to this species. And finally, the life cycle of krill is dependent on sea ice. Sea ice loss due to climate change thus poses a high risk of negative outcomes to this species that is critical both for Southern Ocean ecosystems as well as global food security. So another ecosystem service, primary production, that we can think of as both a provisioning and a regulating ecosystem service. Primary production we can think about as the energy that the transformation of energy into food by plankton at the base of the food chain. And this can be thought of as a provisioning ecosystem service in that exploited species like krill are dependent on primary production, but we can also think of it as a regulating ecosystem service, given the ways in which primary production assists in the regulation of nutrient and carbon dioxide circulation throughout the world's oceans. So ocean acidification and sea ice loss pose a medium to high risk to outcomes to primary production, given the fact that many primary producers are rich in calcium, as well as the complex relationship between sea ice and sunlight penetration into the Southern Ocean, which can regulate productivity. So moving now to the third line, while there remains a relatively low risk of negative outcomes to the blue carbon pathway, given the importance of organic carbon capture in the mitigation of climate change impacts, even a small decrease in the effectiveness of this pathway could have major future impacts. And finally, thinking about risks to cultural ecosystem services such as tourism and recreation can be described as medium. Indeed, if sea ice loss can make parts of the Southern Ocean more accessible to tourists and tourism. However, this very accessibility of tourists can pose its own risk to the Southern Ocean. And as outlined above, the risks related to other aspects of the ecosystem and ecosystem services due to sea ice loss could reduce the amount of biodiversity that could nonetheless be appreciated in these cultural ecosystem services. Yes. Moving on to thinking about the ways in which biota in the system are affected by climate change and the ways in which they contribute to ecosystem services, what I want to drive home here is the fact that climate change impacts species differently, depending on their local environment in the Southern Ocean and depending on the compounding impacts of concurrent drivers. So now Miso examined a range of biota within Southern Ocean ecosystems, from primary producers to top predators. So this table derives from just one of these Miso analyses of the Southern Ocean fish and squid species, but it is emblematic of two major phenomena affecting the entire range of Southern Ocean biota. That is variability in responses between species and among localities, as well as the importance of compounding factors of simultaneous drivers. So in terms of response variability, this can be seen in the negative to mixed to positive responses to different climate change and human-linked drivers that you can see in the green, red, and yellow boxes on the right. And so we can see this among all of the different fish and squid taxa in this table here, but this is also relevant for other types of biota in the Southern Ocean. In terms of compounding impacts, take, for example, the impact of climate change on the commercially exploited fish top predator, toothfish. So the loss of sea ice due to climate change threatens the life cycle of this harvested species, which are dependent on sea ice during their early life stages. So that's one effect. Now, sea ice loss also opens up areas to fishing that were previously inaccessible. So thus, we have the risk of sea ice loss being compounded by both increased risk of negative outcomes for early life stages of toothfish, as well as increased risk of fishery pressure. So in this way, climate change threatens the sustainability of Southern Ocean ecosystems through the compounded impacts of its drivers and further exacerbated by human pressures such as fisheries. So Miso provided a critical service by identifying the key risk pathways affecting Southern Ocean ecosystem services, from climate change impacts on physical drivers in the environment to how these physical drivers affect biological processes, and finally, to the impacts of ecosystem services that provide benefits to people. As we've discussed, the major environmental variables impacted by climate are ocean temperature, ocean acidification, and sea ice loss. These drivers are then linked to climate. Drivers linked to climate change then impact biological processes that are part of ecosystem structure, such as species biomass, species biodiversity, distribution, and connectivity, ecosystem processes, such as productivity and biogeochemistry, And finally, these biological processes are the ones that then provide the ecosystem services that we've discussed, such as provisioning, regulating, and cultural ecosystem services. And these ultimately provide benefits to us as humans. Now, through regional Antarctic policy, we can regulate human activities such as fisheries and tourism in the Southern Ocean on the local scale. However, it is only through global policy that climate change and the impacts of its linked drivers on Southern Ocean biological processes can be mitigated in order to preserve Southern Ocean ecosystem services. So, to sum up, climate change increases risks to Southern Ocean ecosystem services. Human pressures deriving from, for example, the need for food security, increase these demands on ecosystem services. Conservation and management are required, of course, at the local and regional scales to enhance the resilience of ecosystems and to climate change. However, it is only global mitigation that can limit further change and ensure the sustainability of Southern Ocean ecosystems. There's my summary slide. You got to hear it first, and now you get to see it. Okay, so that's everything I have to say to you. What I'm going to do now is pass on the baton to Dr. Susie Grant, and thank you very much.
Thanks very much, Jilda. So the previous speakers have given us an excellent overview of why the Southern Ocean is such a critically important part of the Earth system and the key elements of the first marine ecosystem assessment of the Southern Ocean in terms of the current status and the projected futures of Southern Ocean ecosystems and the services they provide. So I'd now like to look in a little more detail at what these outcomes tell us in relation to conservation and management. So in addition to the global drivers of change, rising temperatures, loss of sea ice, ocean acidification, and changes in wind and circulation patterns acting at the regional scale, Antarctic species and habitats are influenced by drivers acting at the local scale, associated with human activities occurring within the Antarctic region. These local pressures include pollution, both from marine and land-derived sources, the establishment of non-indigenous species, and disturbances caused by tourism or other human visits and scientific activities. Both historical and current exploitation of marine species also continue to impact Southern Ocean ecosystems with increasing demand for harvested resources, including toothfish and krill. There are ongoing changes also associated with the recovery from the impacts of whaling and fishing activities during the past century. And the effects of climate change are causing rapid changes to coastal environments as glaciers retreat, exposing new habitats, and ecosystems are disturbed by the increasing numbers of icebergs scouring the seafloor. As we've heard in the previous talks, Southern Ocean species and habitats have very limited capacity for adaptation to the effects of a changing climate, since they're already highly adapted to their extreme environments. And it's therefore critical to minimize these additional pressures from local drivers and to maintain the resilience of Southern Ocean ecosystems as far as possible through local conservation and management actions, alongside the continuing global efforts to limit or repair climate impacts. So what are the conservation and management actions that would be most effective at achieving this resilience? So there are two critical elements to this. Firstly, management of all human activities in the Southern Ocean must take account of the potential effects and the uncertainties of a changing climate. And this can be termed a precautionary approach, where management actions such as catch limits for harvested species, areas close to fishing, or species given special protection make specific allowances for the projected impacts of human-induced change or for a lack of knowledge about the current future state of ecosystems. Secondly, management must be responsive to change, and this requires up-to-date scientific advice on the current status of marine systems, projections of how they're expected to change, and information on what future scenarios could look like. And so a key objective of MEASO has been to provide this very advice to policymakers for use in management decision-making. An uncertain future in the coming decades means that action must be taken now to implement precautionary and responsive conservation and management strategies at that local and regional scale. One such strategy that can help to minimize the potential impacts of local drivers of change and increase resilience is the establishment of marine protected areas. These are areas where local pressures such as fishing are minimized, which can allow for the recovery of previously impacted systems and provide refuges for Southern Ocean species to exist in the absence of local impacts as far as possible. In some locations, protected areas might also help to maximize the storage of blue carbon by maintaining undisturbed areas of the seafloor. Research and monitoring is absolutely critical to support the implementation of effective and responsive conservation and management strategies by improving our understanding of complex systems, addressing uncertainties, and informing the development of projections. A major outcome of MEASO has been to systematically identify priority research questions and knowledge gaps across a range of disciplines that will be key to improving our understanding of the structure and the function of the Southern Ocean ecosystem, its response to multiple stressors, and its influence on global climate and its projected vulnerability to future change. International research efforts, investment in new technologies and observing systems, improved modeling, and effective monitoring are all critical in providing that scientific evidence needed to underpin effective policy decision-making. So in summary, local pressures on Southern Ocean ecosystems can be controlled or mitigated to varying degrees by conservation and management actions like precautionary fisheries management and protected areas, implemented at that local and regional scale, particularly under the instruments of the Antarctic Treaty System. But in contrast, the regulation of global drivers like increasing temperatures, ocean acidification, sea ice change, these are beyond the capacity of regional management action, and they will require global policy action to reduce emissions, to limit further warming, and particularly through the UN Framework Convention on Climate Change and the agreements reached here at this meeting. Local and global efforts to protect Southern Ocean ecosystems must therefore proceed in parallel. We need both of these things if we're to effectively support the resilience of these ecosystems, limiting further change and ensuring that they can continue to provide the ecosystem services that benefit global society. So I'll now hand back to Sian to introduce the last in our series of presentations with an overview of MEASO implications for policy. Thank you very much.
Okay, thank you very much to all of those fabulous speakers for those really informative presentations on the outcomes of MEASO, the particular focus on the biological systems and ecosystem services, and then what is required in terms of local and regional management in order to protect these ecosystem services. So we're now going to move to some of our online speakers and the video that Nick at the back and Heidi are setting up for us. So excellent tech support, by the way, in the Cryosphere Pavilion. Great to see. So we are now going to watch a video which has been put together by Dr. Andrew Constable from the Institute of Marine and Antarctic Research in the University of Tasmania, and Dr. Jess Melbourne Thomas at the CSIRO in Australia, so the Commonwealth Scientific and Industrial Research Organisation. And it was these two really that came up with the idea of MEASO in the first place, and Andrew led the whole initiative of that team of over 200 scientists, very capably supported by Jess. And the initiative was born, if you like, during their time working together in the Antarctic Climate and Ecosystems Research Centre in Hobart. So it's a pleasure to hand over now to both Jess and Andrew, who will also be joining us for the panel discussion, which will follow this video. So Andrew, Jess, over to you.
Thank you, Sian, and good morning, everyone. It's a pleasure to provide this recorded presentation, and Andrew and I look forward to joining the panel session live after our presentation on the implications of MEASO for policy. We would like to start by acknowledging the traditional owners of Arctic and holds global significance as a heat and carbon sink. It's a place that
fisheries, productivity, biodiversity,
on the detail of what Andrew was saying there. The different colours depict different states of the ecosystem. So the blue colour was that temperatures are remaining within the thermal tolerance of the animal, of most of the animals that live there, and therefore we can consider the ecosystem to be relatively stable over the timescales that were displayed. The red colour depicted that the majority of animals within that ecosystem are under thermal stress, and therefore they're struggling, they're not able to reproduce and to grow and to thrive as they would if they weren't under that thermal stress. And the black colour means that the temperature is far too high for those ecosystems to be able to continue to function in the state that they have become adapted to over the last 25 million years. So I think we're ready to go again from the back. Yep, great. So back over to you, Andrew, and apologies for the technical difficulties.
Thank you, Sian, and good morning, everyone. It's a pleasure to provide this recorded presentation. Thank you, Sian, and good morning, everyone. It's a pleasure to provide this recorded presentation, and Andrew and I look forward to joining the panel session live after our presentation on the implications of MEASO for policy. We would like to start by acknowledging the traditional owners of the land and sea country where we live and work in Lutruwita, Tasmania, the Muwinina people, to pay our respects to their elders, past, present and emerging, and to recognise their deep knowledge for responding to climate change and truly caring for country. So as you've heard from Sian, Nadine, Jilda and Susie, the Antarctic and Southern Ocean is home to an ecosystem that holds global significance as a heat and carbon sink. It's a place that captures the imagination of people around the world and also supports fisheries and tourism. The Antarctic is a key part of global ocean circulation, where carbon and nutrients sink to the bottom of the ocean and travel around the world. Phytoplankton and krill form the foundation of a marine world where some species travel from the equator every year, while others depend on ice environments for food and breeding, where corals and sponges and bottom-dwelling species have evolved in freezing waters and need those waters to remain cold to be able to survive. Right now, the Southern Ocean needs climate change mitigation to continue the ecosystem processes and functions that everyone needs. I ask you to consider two possible futures for Southern Ocean ecosystems. By limiting warming to 1.5 degrees, we can preserve and maintain the key things we care about and depend upon from the Southern Ocean. Beyond this level, our current scientific understanding is that ecosystem services will be degraded and that we may lose elements of the system. Loss of sea ice in particular will have cascading effects for key species, food webs and ecosystem services. At 2 degrees of warming, the risks are very high and it's unclear whether recovery would ever be possible. From a Southern Ocean ecosystem perspective, we must limit warming to below 2 degrees, and even then we will see some loss and significant change, which we will need to manage through local and regional actions. What happens in the Southern Ocean affects everyone. The global population is the Antarctic population. We all have an interest in maintaining a healthy Southern Ocean ecosystem. Investment in observations and dynamic ecosystem modelling at the circumpolar scale is critical to help resolve what the alternative futures look like and the consequences for ecosystem services. And alongside the biophysical values of the Southern Ocean ecosystem, I would argue that we must also acknowledge the importance of our cultural connections with it. Connections that future generations have an equal right to enjoy. Thank you, and over to you, Andrew.
Thanks, Jess. Good morning, everyone. So what is at stake for Southern Ocean ecosystems? And what roles do each of us play? The 4 ecosystem services represent our different perspectives, and in Antarctica, these are fisheries, productivity, biodiversity, and cultural values. These services are affected by different human drivers of change. Now the size of the arrows here gives some indication of their relative importance. Local drivers include fishing, tourism and national operations, while global drivers are mainly through effects on the atmosphere. The value of ecosystem services are dependent on our cultural values, often represented through non-government organisations. Advice on how ecosystems are changing comes from many programs. Most science is on drivers of climate regulation and productivity, and on targeted fishery species like toothfish and Antarctic krill. Some science investigates the broader ecosystem, but this is much less. Management of local drivers rests with the Antarctic Treaty System. Its goal is to protect and maintain the polar ecosystems. As yet, there is no plan for managing for a changing ecosystem, including from rising temperatures and ocean acidification. Except for ozone, there are also no regulations protecting Antarctic polar systems from harmful global change, and this is a big gap. How much is the ecosystem changing, and are possible changes through global warming dangerous for Southern Ocean ecosystems? Rising temperatures are the greatest threat at present to Southern Ocean ecosystems. Here is a scenario from an Earth system model to help draw together conclusions of MEASO. It runs from 1900 into the future. What is important here is not the emissions scenario, but the state of the polar system for given global warming levels. Dark blue represents sea ice cover and light blue represents optimal polar temperatures. Red shows temperatures causing heat stress in polar species. Black is when the temperatures are too high. The circle is the area of the Antarctic Treaty. Now, when seen in rapid sequence, the annual pulsing of sea ice shows how the Southern Ocean is the beating heart of the ocean systems. The Antarctic polar system remains relatively stable up to the present. The recovery of the ozone layer has delayed impacts of global warming. The main point to watch for here is this. As the level of global warming increases past 1.5 degrees, the polar system becomes more erratic over spring and summer. And then after 2 degrees, the scale of the polar system becomes substantially reduced over summer. There are 4 important areas of change in Antarctica. The West Antarctic Peninsula is the area of most rapid recent change, and it will have increasing reduction of sea ice along with substantial warming. East Antarctica is also a place of future warming. The Weddell Sea and the Ross Sea are the most southern marine places on Earth and areas to watch. We have confidence in these results because the model is from the ensemble of models used to underpin IPCC assessments. It is one of the best from the ensemble for representing the Southern Ocean. In summary, these panels show an average state of the polar system for 4 different global warming levels at the end of summer. Just to remember that spring and summer are the most important times for growth and reproduction in polar species. By 1.5 degrees, the summer warming extends stressful levels from the West Antarctic Peninsula further west. Ice-dependent species will become restricted in their ranges. By 2 degrees, the Weddell Sea and the Ross Sea are warming and starting to lose the presence of summer sea ice. After 2 degrees, there is increasing warming and loss of ice in East Antarctica and from the West Antarctic Peninsula to the Ross Sea. Ecosystem structure will be changing. The Ross and Weddell Seas are likely to provide some refuge to the effects of global warming. Given the scale of the region, many areas around Antarctica will need to be maintained as refugia. Those areas will need to be specially managed in order to maintain the resilience of biodiversity. Miso has linked species responses to changing habitats. Based on that assessment, we conclude that the Antarctic polar ecosystem and its ecosystem services will be at great risk if global warming levels are not kept below 2 degrees.
Of sticking through that one. What happened was we lost sound to the live stream, so when we could still hear in the room, the live stream could not. So we decided just to start the video again, and people in the room get to see a goodly portion of it twice. So hopefully you enjoyed that, and hopefully it enabled you to solidify those important messages in your mind all the more. So we're now going to move into the panel discussion. So I'm going to invite Nadine, Jilda and Susie onto the stage with me. And I'm also going to invite, if the tech allows, Andrew, Jess and Juan onto the screen from their respective corners of the world. So let's start to move the chairs around and hope that we see people coming in from Australia and Chile. So what we've been doing to prepare for this panel discussion is to have a social media campaign in the week leading up to this session, where we've invited questions from a much larger audience than can be with us today, or who are willing to sit and watch a live stream on a Saturday morning or other times on a Saturday in different parts of the world. So we do have some questions that have come in over social media, both in the last hour or so and also over the course of the last week. But before I start, there are 3 people joining us on the screen now who you have not met yet. So there's Dr. Andrew Constable in the top right, who you just saw in the video, Dr. Jess Melbourne-Thomas in the bottom right, and Dr. Juan Huffer, who is a face that you have not seen yet, in the bottom left. And Juan is one of the lead authors of the MEASO initiative, and he is a researcher based at, and I'm going to try it in Spanish, apologies for pronunciation in advance, but the Pontificia Universidad Católica de Valparaíso. So hopefully that Spanish pronunciation was all right for Juan and anybody else who speaks Spanish in the audience. So welcome back to the stage, Nadine, Jilda and Susie, and welcome Andrew, Jess and Juan. So Andrew and Jess are coming in from Hobart, Tasmania, so it is getting late on a Saturday evening for them. And Juan is joining us from Chile in quarantine before he goes on his Antarctic field season. So very early in the morning. Juan, thanks for joining us. And so for questions from the audience here today, there's good attendance, so thank you all for coming. If you'd like to ask a question, if you could just approach the microphone just in front of Tom there to ask your question, you'll be very welcome. And just to start us off in this panel discussion, we had a question that came in over social media, which was about the regional impacts of Antarctic change in regions that are not Antarctica. So Juan, I'm going to come to you for this question. So we've had in the talk several examples of regional changes around Antarctica. Andrew did a great job in the video just there, showing which regions were most at risk. But the question is really about effects in regions much more distant from Antarctica, and perhaps whether there are some examples that people can relate to who haven't necessarily been to Antarctica itself. So again, coming back to the global connectivity of the Southern Ocean system and the changes underway. So Juan, over to you.
Thanks, Sian. Hi, everyone. So happy to be here. Yeah, as you were saying, well, for me right now, I am I think a little bit over 1,000 kilometers away from Antarctica. So I am the closer one from there, I think, right now. So it feels much closer than other parts of the world. But well, as Andrew and Jess also know, for places like Chile, Argentina, Australia, the impacts that the dynamics occurring at the Southern Ocean and in Antarctica have on the countries and their agricultural product, how they produce agricultural food and other things, you can feel it like in your everyday. For instance, we know that the wine production in Australia, Argentina, and Chile, it suffers depending on how the dynamics in the Southern Ocean and in Antarctica are occurring. So even if you don't care so much about Antarctica, but you care about drinking wine, you should care about what happens down there. And since the Chilean wine and Argentinian wine drink worldwide, so everyone should be concerned.
Thank you, Juan. And I think we can all agree that we can relate to the quality of Chilean wine as a really important impact of Antarctic sea ice changes. So thank you very much for that. I'm going to keep an eye on the back of the room in case there's anything coming over the live stream. But another question that we've had from Twitter in the last couple of days feeds directly into the conversations that we're having at COP about whether we need to agree on 2 degrees of warming or whether it really is 1.5 that we need to be aiming for, and indeed what the difference is for Antarctic marine ecosystems in particular, depending on whether we meet the 2 degree target or the 1.5 degree target. So I think, Andrew, I'll come to you on that one first and then open up to other speakers.
Thanks very much, Sian. Good morning, everybody. It's certainly a pleasure to be coming here from Hobart. Just to the difference between 1.5 and 2 degrees, as Jess indicated in her part of the presentation and is also demonstrated in the simulations, is that the uncertainty increases greatly as we move beyond 1.5 degrees. And critically, what we've seen in our work and what we see when we look at those future simulations is that the instability that arises, particularly in the West Antarctic Peninsula and in East Antarctica, may cause complete shifts in the system away from krill, because it will become inhospitable to krill. And that will have great impact on the whales that use those areas as their summer feeding grounds. And so the notion of being able to manage to 2 degrees would present still high risks for the Antarctic marine ecosystems.
Okay, thank you. I'll now open up to any other speakers who'd like to contribute to that answer. So, Jess, I'm going to see if you want to add anything to that.
Thanks, Sian, and hi, everyone. I'm a bit worried we're getting a bit of an echo, actually, from the online feed. Can you hear that too? Yeah. So I think Andrew captured it very well. I might just stay on mute until we're certain that the echo is sorted. Thanks, though.
Thanks, Jess. I think the echo it sounds all right to us in the studio. So I think we'll keep rolling, and I'm getting a nod from the tech team at the back. Right, so I've actually just had a question over Twitter right now, which is looking for a bit more of a good story, a good news story. So we've talked a lot about the danger to Southern Ocean ecosystems of warming and ocean acidification and ecosystem services. But this question here asks whether there are any ecosystem services that are going to benefit from the warming that we're seeing and the sea ice losses. And if so, how far do they go to offsetting the negative impacts that we've focused on for the talk? So I think for that, I will come to Jilda first and then on to Susie, perhaps.
Thanks, Sian, for that question. I don't know if I'm necessarily the best one equipped to answer it. Indeed, all of what I discussed was a bit of doom and gloom. I necessarily was highlighting some of these sort of doom and gloom examples. It's true that a bit of the complexity of the impacts on biota and ecosystem services derive from the fact that it's a mixed bag. For example, there's not a lot of evidence that bad things will happen to squid, for example. But also something that I didn't talk about too much is that, well, we just don't know a lot. So there's a lot of question marks. We know some bad things, we know some okay things, and then there's a lot that we don't know. I don't know if I could cite any examples of things that we know are going to be good, but perhaps I could open that up to the other panelists to see if they might be better equipped to have a positive story on warming.
Okay, I think we'll go over to Susie.
No, I think that's a good answer, Jilda. I think there will certainly be some species that are seen as losers in this changing climate that don't do very well. There may be others which find that they can do quite well in the changed environments. Species may be able to move into new environments, perhaps new areas that opened up with the loss of ice that may allow some species to do better. But I think on the whole, this is really, it's a change. It's an enormous change. As Jilda says, we can't predict how that will play out. And I wouldn't necessarily see that as a benefit to the system as a whole. It may benefit some individual species, but that change and the consequences of those changes across the whole ecosystem, I think we can't really term as a benefit. And it is also a very unpredictable situation where we probably don't know enough about how those different species are likely to interact with each other in that changing environment. So I think, yeah, I'll leave it there if anyone else wants to add to that.
Yep, please do.
I'll just add to that by saying that the good news is that we actually can do something about it. We do have the power to address climate change, to mitigate and limit that warming. That is within our power. And not a solution as such, but the vast populations of biological organisms in the Southern Ocean have the ability to help with that carbon dioxide drawdown, the sequestration and the export of the carbon for the system. So as long as we give them the options to support their resilience, to foster their resilience, and preserve that structure and functioning as far as possible, then it can be a good news story.
Great, thank you very much. And Andrew, you had something to add as well, so coming to you now.
Yeah, thanks very much. It is a very good question. One of the great difficulties that we have is our science to date has been very focused on the polar species, and they've been also very focused on krill and whales and fish that have been over-harvested in the past, and while measures now are sustainable, they're still the focus, and we need to start trying to understand what the other organisms might be doing, and to see what might happen if there are shifts in the food web. And so it's one of the things about polar systems for the Arctic and also the third pole in the mountains, that these are on the edge of the limits of climate change. And it's very hard to manage for a positive news story. But as people have said already, we can do something about it, and we've been able to highlight some of those measures.
Thank you very much. Back to Jilda.
I'll just make one closing point on this. To quote Jeff Goldblum from Jurassic Park, life finds a way. I think the question is not what species are not going to do well, what are some good news stories for species? Certainly there will be. The question is, how is that, we're looking at this rather selfishly, how is that going to impact humans? How is that going to impact ecosystem services to humans? Yes, in a warming environment where we may no longer exist, there will be plenty of very happy ecosystems. The question is, how is this going to affect us? And that's where the difficulty is to find a good news story.
Thank you very much. Okay, so I think we've got about 5 minutes left, so we'll just take one more question. And as there's nobody jumping up and down in their chair, oh, yes, there is. Please do come up to the mic. And if you want to introduce yourself quickly so we know who you are.
Hi, my name is Dr. Elizabeth Chan. I'm an environmental humanities scholar from the University of Warwick. I work mainly on Patagonia, so it's been really brilliant to hear all the insights you've offered. And my question was sort of more policy related and sort of, I guess, humanities related as well. I think you all sort of tapped into the fact that a lot of the research that's been going on has obviously been being done by countries that are kind of bordering or involved in the Antarctic Treaty sort of organization. And I think it's interesting to think about how many people kind of outside of the policy and science spheres perhaps have ideas of Antarctica as a kind of static or immovable place, in spite of the fact that the enduring and most powerful images of climate change are often pictures of melting ice. And I wondered if you had any kind of insights or thoughts into how perhaps we can communicate those messages about the kind of severity of the impacts of warming and acidification in the Southern Ocean to, I guess, to sort of the general public in a better way, particularly for those of us that are working in the sort of humanities fields. Thank you very much.
It's a fantastic question and a really important one about how the sciences and the humanities need to work together to solve these global problems. So thank you very much for that. I'm going to come to you, Jess, because I think this is right in your sweet spot. And then perhaps we'll go to Susie afterwards, just in case you've got anything to add. So Jess, over to you.
Yeah, sure. Very happy to comment on that question, Sian, and it's a really important question, and I'm glad that issue was identified, and Andrew may also wish to comment on that. I think, it's interesting to observe that we understand and appreciate rates of change in the Arctic, and yet there does seem to be, a conception that the change in Antarctica is not to the same extent, and something that we've been trying to do through MEASO is to draw attention to the fact that we're really on the cusp of seeing very rapid change occurring in Southern Ocean ecosystems. And in fact, an important part of the MEASO work was to try to build in an identification of how we can use cultural connections in our communication to policy making to help bridge that gap that I couldn't see who was speaking there with the question, but exactly that gap that was raised there around, how do we better bring that cultural connection into the story and actually, I guess, reach into people's hearts in terms of what's at stake in terms of loss in the Southern Ocean.
Thank you very much, Jess. And now come to Susie.
Yeah, thank you, Sian, and thanks for the great question. I think it's a really important one. And certainly, I think we here in the Northern Hemisphere in the UK, we do feel quite removed from the Antarctic. It's different for our friends in Hobart and in Chile. I think possibly there's a little more feeling of being connected, that the Antarctic is just the other side of that ocean that you can see out of your window. But certainly, in a lot of parts of the world, it feels extremely distant. And the Antarctic is not a place that very many people will have the opportunity to visit. So we rely a lot on, fantastic nature documentaries. People very much enjoy seeing images of the Antarctic and all of the wildlife there. But I think we do have to find ways of bringing that connection closer to people. I think one of my favorite maps, I think, was shown in a couple of the slides by Sian and maybe by Andrew and Jess as well, of that image of the world ocean as a single ocean. Antarctica is a continent in the middle of it, the Southern Ocean surrounds it, and then that connects to every other part of the ocean. It is a single world ocean. It's not a number of separate oceans. And I think trying to really push that message as far as we can, that this is all of the ocean circulation that is coming out of Antarctica will eventually make its way up to the Northern Hemisphere. It will affect us here. That connection across the Earth system as a whole is really important, and I think that goes for all of our discussions on a changing climate. There is so much connection, and it's not just little bits of the Earth that we need to look at separately, but it is all of it. But I do very much agree with you that I think we need to communicate that message very well. So thanks for the question.
Thank you. And a quick point from Nadine.
Yeah, thanks, Susie. I'd also like to add to that. Traditionally, as scientists, we tend to work within our own disciplines, and more recently, we've been working in a much more multidisciplinary fashion. But there's a much bigger global move from our Earth system research programs to integrate social scientists from the beginning. So we really need to draw in the perspective of human needs, human uses, human presence in the Southern Ocean. And we've already started to do that. It's new for all of us. We speak a different language. So it's finding that common ground, and perhaps that's one of those keys into integrating society better into our research.
Okay, I'm going to draw the discussion to a close there. There are more questions coming in from the live stream, but we unfortunately don't have time to answer them. However, we will answer them afterwards, and we will communicate them by social media. So thank you all for your incredible engagement, that we did not have time to go through all of those questions, but we will continue this dialogue going forward. So I want to thank all the speakers for attending today. So again, Dr. Andrew Constable, Dr. Jess Melbourne-Thomas, and Dr. Juan Hofer joining us from very far away in the Southern Hemisphere, much closer to Antarctica than we are now. Dr. Susie Grant, Dr. Jilda Caccavo, and Dr. Nadine Johnston here with us in Glasgow. And hopefully between the 7 of us, we've managed to convince you that Southern Ocean ecosystems are globally important for biodiversity, for nutrient cycling and redistribution, and for carbon dioxide uptake and therefore regulation of the global climate. These systems provide critical ecosystem services, both regionally, but also for the entire global human population. And these systems are under pressure and increasing pressure, and they need to be protected and conserved long into the future. And in order to safeguard these systems, we need global policy on climate change mitigation, hence where we are at COP26. And we also need this to go hand in hand with local and regional conservation and management measures in order to enhance the resilience of these ecosystems to the changes in climate and the environment that we cannot prevent. So by having more resilient ecosystems and effectively mitigating global climate change, we can safeguard these ecosystems for the entire human population. Thank you all for your attendance, both in the studio and online, and thank you to the tech team at the back.